3. The Second Great Flood Stage, the Coral Period, the Brachiopod Age. 300 million years ago, another great period of land submergence began. The southward and northward encroachment of the ancient Silurian seas made ready to engulf most of Europe and North America. The land was not elevated far above the sea, so that not much deposition occurred about the shorelines. The seas teemed with lime-shelled life, and the falling of these shells to the sea bottom gradually built up very thick layers of limestone. This is the first widespread limestone deposit, and it covers practically all of Europe and North America, but only appears at the Earth's surface in a few places. The thickness of this ancient rock layer averages about 1,000 feet, but many of these deposits have since been greatly deformed by tilting, upheavals, and faulting, and many have been changed to quartz, shale, and marble. No fire rocks or lava are found in the stone layers of this period, except those of the great volcanoes of southern Europe and eastern Maine, and the lava flows of Quebec. Volcanic action was largely past. This was the height of great water deposition. There was little or no mountain building. 290 million years ago, the sea had largely withdrawn from the continents, and the bottoms of the surrounding oceans were sinking. The land masses were little changed until they were again submerged. The early mountain movements of all the continents were beginning, and the greatest of these crustal upheavals were the Himalayas of Asia and the Great Caledonian Mountains, extending from Ireland through Scotland and on to Spitzbergen. It is in the deposits of this age that much of the gas, oil, zinc, and lead are found, the gas and oil being derived from the enormous collections of vegetable and animal matter carried down at the time of the previous land submergence, while the mineral deposits represent the sedimentation of sluggish bodies of water. Many of the rock-salt deposits belong to this period. The trilobites rapidly declined, and the center of the stage was occupied by the larger mollusks or cephalopods. These animals grew to be 15 feet long and 1 foot in diameter and became masters of the seas. This species of animal appeared suddenly and assumed dominance of sea life. The great volcanic activity of this age was in the European sector. Not in millions upon millions of years had such violent and extensive volcanic eruptions occurred as now took place around the Mediterranean trough, and especially in the neighborhood of the British Isles. This lava flow over the British Isles region today appears as alternate layers of lava and rock 25,000 feet thick. These rocks were laid down by the intermittent lava flows, which spread out over a shallow sea bed, thus interspersing the rock deposits, and all of this was subsequently elevated high above the sea. Violent earthquakes took place in northern Europe, notably in Scotland. The oceanic climate remained mild and uniform, and the warm seas bathed the shores of the polar lands. Brachiopod and other marine life fossils may be found in these deposits right up to the North Pole. Gastropods, brachiopods, sponges, and reef-making corals continued to increase. The close of this epoch witnesses the second advance of the Silurian seas, with another commingling of the waters of the southern and northern oceans. The cephalopods dominate marine life, while associated forms of life progressively develop and differentiate. 280 million years ago, the continents had largely emerged from the second Silurian inundation. The rock deposits of this submergence are known in North America as Niagara limestone, because this is the stratum of rock over which Niagara Falls now flows. This layer of rock extends from the eastern mountains to the Mississippi Valley region, but not farther west, except to the south. Several layers extend over Canada, portions of South America, Australia, and most of Europe, the average thickness of this Niagara series being about 600 feet. Immediately overlying the Niagara deposit, in many regions may be found a collection of conglomerate, shale, and rock salt. This is the accumulation of secondary subsidences. This salt settled in great lagoons which were alternately opened up to the sea and then cut off, so that evaporation occurred with deposition of salt, along with other matter held in solution. In some regions, these rock salt beds are 70 feet thick. The climate is even and mild, and marine fossils are laid down in the Arctic regions. But by the end of this epoch, the seas are so excessively salty that little life survives. Toward the close of the final Silurian submergence, there is a great increase in the echinoderms, the stone lilies, as is evidenced by the crinoid limestone deposits. The trilobites have nearly disappeared, and the mollusks continue monarchs of the seas. Coral reef formation increases greatly. During this age, in the more favorable locations, the primitive water scorpions first evolve. Soon thereafter, and suddenly, the true scorpions, actual air breathers, make their appearance. These developments terminate the third marine life period, covering 25 million years, and known to your researchers as the Silurian.